myself. My name is Charles Camarda. I grew up in Queens, New York. I graduated from Polytechnic Institute of Brooklyn at the time. Now it's the Tandon School of Engineering at NYU. I was an intern at NASA Langley Research Center the summer between my junior and senior year, and I worked at NASA Langley. And it was then that I realized that I really loved. I was in the aerospace engineering department at Brooklyn Polytech, and I realized that I really loved research. And so I applied, and luckily, because I did that internship and they liked me, they hired me, and I was doing research in advanced materials and structures for hypersonic vehicles, thermal protection systems, cryogenic tanks, actively cooled structures, hot structures, and the like. And always wanted to be an astronaut. That's what drove me into science. Actually, I was always interested in science, but when I was a child, it was all about the space race with Russia, and they were the evil empire. It was us against them. And it was this competition that was played out on TV. And every young child at that time dreamed of being an astronaut. I always loved science. And so that's what kind of kept fueling my passion to continue going to get degrees and advanced degrees. When I was working at Langley, I received my master's degree at George Washington, and with classes taught on site. And then I went away for my doctorate at Virginia Tech because one of the amazing people that mentored me during my internship was a postdoc, a doctoral student from Technion, from Israel. Dr. Rafi Hafka went to aerospace and ocean engineering, and I worked with him. He was a colleague, and then when he was teaching at Virginia Tech, I knew that that's where I wanted to go back and study with Dr. Hafka. Oh, and I applied to be an astronaut once when I had minimum requirements, and they allowed non test pilots to become astronauts in 1978. I only had my undergraduate degree, and then I waited till I got my advanced degrees, and then I reapplied, and I got lucky. Was my mission significant? We flew in 2005, 2.5 years after the Columbia accident. And this is when I realized I was training in Russia when the accident happened. And this is when I realized that NASA really had some serious problems. How could really good engineers, program managers, watch this large piece of foam impact the lower portion of the left wing of the orbiter and not realize that that would have caused critical damage? We had some serious problems at NASA. And when I returned from Russia, I started developing these different teams, working with the experts that I used to know and worked with throughout my career in hypersonics around the country, pulling together these teams to understand what caused the accident and also to help design technology that we could fly, that other astronauts could fly, to ensure that we would fly safe. And so this was before I knew I was going to be selected for that next mission. And I was surprised when I got the nod and was selected to be on that mission. But what was important about that mission was we had to rapidly develop new technology, test it in space, and validate that it would work in order to ensure that not only we would be safe, but all the successive crews that flew on shuttle until its retirement in 2011. So it was a geeky astronaut's dream to work on this mission with an amazing crew. We had two amazing ladies on our crew. Eileen Collins was the commander, test pilot, Air Force test pilot, and Wendy Lawrence was a naval aviator. She flew helicopters in the Navy. So It was a dream mission, and I was very lucky. Like I said, I flew after the Columbia, and no one talked us out of going. Many people wondered, how safe we would be, but because I worked with so many of the teams that were helping to build the technology to keep us safe, and we had many options in case we did have another problem similar to a debris strike that took down Columbia, I felt very confident. Um, it was very emotional from the standpoint that we were the next crew, and we had just lost 2.5 years prior to that our friends. On shuttle missions back in the day, they were typically 14-day missions. And so it's real exciting. The launch is real exciting. You're sitting there for 2.5 hours waiting for the solid rocket motors to light up and take you into space. Um, and then once you get there, the shuttle missions were really crammed, a really packed day with lots of work for the astronauts to do, either spacewalks, logistics. We were either fixing things on the space station, we were conducting experiments. And so our mission was like a typical shuttle mission, except that our timeline was very crammed with new technology and new experiments that we had to work on in a very compressed timeline. We did do one repair. Suichi Noguchi and Steve Robinson did a spacewalk, and they basically swapped out, like changing a flat in space, only this was a 600-pound control moment gyro that they swapped out in an amazing spacewalk. Another thing, we had some anomalies on our mission. We had a large piece of foam break away from the side of the vehicle in a protuberance airload ramp, a POW ramp. Just missed our left wing. It would have been very critical if we got hit with that piece of foam. We hit a large buzzard on launch that luckily fell on the backside of the external tank that could have caused a problem. Another thing that was really critical was that when we did our rotational our R-bar maneuver, basically we when we're getting ready to dock with space station, a new maneuver, we basically do a backflip. Eileen commands a backflip, and the uh, uh, people on space station at that time, John Phillips and Sergei Krikalev, basically photographing the vehicle as we do this backflip to basically inspect the bottom of the vehicle, see if there's any damage. Um, and so what we noticed on the ground that there was a very small piece of gap filler, like a thin felt like material that's in between all of the thousands of shuttle tiles on the belly of the vehicle. It was sticking out in two places, about a half an inch. And the amazing people on the ground, some of my good friends in the Friends of Charlie network at NASA Langley, they were able to determine when they saw this gap filler sticking out that if we didn't do an emergency EVA, an emergency spacewalk, and pull that gap filler, that when we flew back in through the Earth's atmosphere at Mach 25, 18,000 miles an hour, it would trip the boundary layer and these vortices would shed, would hit our wings and burn our wings up. So that was pretty exciting. I mean, what we're seeing now, I mean, it took us so long to get to this point. We've watched this happen in aeronautics, only it happened much quicker in aeronautics, how the commercial sector ramped up and has taken travel in the air around the world to a new level. And now we're hoping to fly at supersonic speeds and possibly one day hypersonic speeds around the earth, right? And so now we're seeing this commercial venture which I think excites the creativity. It excites people. More people are going to be in space of diverse backgrounds, not just scientists and engineers, those left brained, logical thinkers, but more creative out there, writers. poets, artists. Everyone will hopefully get the opportunity to experience space. And I think the creativity and entrepreneurship will make space safer. It will make it much less expensive, and it will offer up many new opportunities here on here on Earth. And so, when I was a young man, there were dozens of aerospace companies. Now up until recently, we only had maybe a handful of aerospace companies like the big Boeings, the Lockheeds, the General Dynamics, and now we're seeing lots of new space companies opening up, doing very exciting things, very innovative things, the way NASA used to work, reusability, and what's happening with SpaceX. And so I think this is a great time for tourists, for entrepreneurs, and for technology development. What I really hope to witness in my lifetime are humans stepping foot and actually living on Mars or a moon of Mars. I would really love to see that. Why did education become a passion for me, right? Because I was not a teacher, I was not an educator at the time. But after the accident, I realized how badly we were doing in educating and training some of our own junior engineers. I watched people make really bad decisions when we had the capability at other NASA centers to make the right decisions. And so I developed a program to do this. I mean, when I realized what was wrong, I realized that the way I was taught engineering as a research scientist and engineer at NASA Langley was the right way. And so I developed a methodology called innovative conceptual engineering design. And with the help of professors from MIT, Penn State, and Georgia Tech, we created a curriculum, and we taught this curriculum to a group of 30 junior NASA engineers offsite at Penn State, a 1 week short course. And we called it the Epic Challenge Program. I call what I do the Epic Challenge Program because we try to pick challenges that are so complex and so daunting that even NASA can't solve them. And so my manager at the time, my supervisor at the time said, Charlie, if you think you could do this, go ahead. I'll give you the money. You create this course and do this. And I said, I'll do it, but I want to pick a problem that even NASA can't solve to prove that this will work. And so we zeroed in on land landing of a capsule. As you know, NASA and the United States is still trying to land their capsules on land. The Russians land on land. And so we created this methodology. We had these 30 engineers on site, and during that time, we taught them how to think creatively. And we infused the creativity within the curriculum. We gave them different tools to work, not only individually creative, but to work together in teams creatively. And so the teaming aspect of how you do this is very important. And what was amazing was in only 1 week, we had dozens of really cool ideas. We took one of those ideas, and with a little bit of funding, with a master's degree student at MIT and some undergraduate students from Penn State and Georgia Tech, they came up with an airbag design inside the Orion space capsule that would basically provide a cushion and enable astronauts to land the capsule on land safely. What impacted me about Virginia Tech? Number one, it was in a beautiful setting in the in Blacksburg, Virginia, up in the mountains, right? And it was also very cold, right? And so it was ideal for studying in the wintertime. And me, I was kind of older than most of the graduate students there because I did this later in life. I was went for my doctorate when I was about 35 years old. or a little bit younger, a little bit younger. And so most of the students there that were going for their PhD had been going straight. And so it was very fresh in their mind. So it was a very long time since I specialized in structures, and so it was a very long time since I had control courses, aerodynamics courses. And so now I was taking these graduate courses. So it was a very intense experience in Virginia Tech. But they were great people, great students. I had a lot of fun in addition to doing a lot of very intense studying. And they had amazing faculty, and the person that I relate to that I went there to study from was Professor Raphael Hafka, and he just recently passed away. He left Virginia Tech and went to teach at University of Florida, Gainesville, and we just lost him this year. And just had amazing professors, not only in the aerospace engineering department, but I also took courses from civil engineering professors like Ray Plout, with amazing nonlinear dynamics. I studied with him, and so it was a very intense time, but I still have very many great memories of being in Virginia Tech and on campus there.